plus s over 2 is equals to 0. Can we write this like this?
Yeah,
Okay, so now you already know. If we can write it in this way, then it would be log of 4 v dash plus v plus integration of s over 2. You guys did not notice this will come with the denominator now, isn't it?
yeah,
Here.
1/2. Yeah,
Yeah. You are making the same mistake which I am doing. 1 over 2 of s and logarithmic of s 1 over 2 is equals to 0, isn't it?
yeah.
Cross verify again one time more my calculation because I am thinking that I might make a mistake. So I took s common 4 v double dash plus v dash plus 1 over 2 4 v dash minus this. And then
I get the same when I try to solve that.
okay, then fine. Then I am proceeding in a right way. 4 v dash plus v square root of s is equals to 0. So is it possible to take s equals to 0? Because s equals to x square over t, isn't it? Some constant say. And for the sake of convenience, take this constant equals to 0. For the sake of convenience, this is the solution. So is it possible to take s equals to 0? No, because if you will be taking s equals to 0, then x have to be 0. So what is the possibilities? See, now since we are solving a very typical question, typical problem, so we have to make some little bit assumption. You can take it like this. You can take it like this: 4v dash plus v equals to constant over root s. But in that case, when you are going to solve it, so it will be like 4v dash over v plus 1 equals to cos of square root of s into v, or it will form the it will be form a differential equation which we need to solve with the help of integrating factor, isn't it? What kind of method you can choose to solve this differential equation?
Multiply
Except
by an exponential function, something. See, something like that. It's a linear differential equation.
Yeah, so you need to choose the integrating factor like this, isn't it? No, 1 dot ds, because the product of this is 1. So e to the power s, and then the solution will be v e to the power s is equals to integration from cos of square root s e to the power s ds plus c, isn't it?
But
Something like that.
I think that you need to divide by 4 before to make the integrating factor, because I think that the
Yeah, I got.
yeah,
Yeah, but now the difficulty arises when you are going to solve this,
yeah,
because when you will be proceeding to solve, so that's why, to make it easier, one can take this constant equals to 0 just for the sake of convenience. I am not saying that it is a very general solution, but at least I can say that okay, we are having an exact solution, because you guys know that finding an exact solution of even a simplest PD is very difficult. So you can take this small assumption, so don't worry about that. Now Since we are taking constant equals to 0, so we have this differential equation. And what is the solution of this differential equation? V dash over V plus 4 equals to 0. You will send it on that side. So, and you will differentiate it. So it is going to be logarithmic of V is equals to minus, oh, 1 over 4. Every time I make a mistake, minus s over 4 plus some constant. Take that constant 0. So V equals to e to the power minus s by 4. And since we have the form of V, now we only need to find out the form of W. Since we have chosen lambda equals to minus 1 over 2, so this differential equation becomes W dash T over W T, minus minus will be plus, so 1 over 2 T equals to 0. See, I can make a lot of mistakes, so don't trust me. You can cross verify my calculation. So it will give us logarithmic of W is equals to minus 1 over 2 logarithmic of t plus some constant. Take this constant equals to 0. So W logarithmic of W equals to logarithmic of t to the power minus 1 over 2. So W is equals to t to the power minus 1 over 2. So we have the form of W, we have the form of V. And what we assume, we got that the solution is going to be of the form U x comma t is equals to WT and V of x square over t. So V, if we write it in the form of x square over t, so minus s is x square over 4t. So what will be the complete solution? The complete solution will be u of x comma t. W is t to the power minus 1 over t, so we can write 1 over square root t. And this is exponential of minus x square over 4t. Do you guys agree with this solution? If anyone has any small doubt, then please do ask.
So we find
So
that solution.
this is
Sorry, we find that explicit solution making some assumption for the constant in each differential equation.
yeah, yeah, we can see that here we have taken all the constant 0 because we are just solving this differential equation, isn't it?
Yeah.
Now any kind of initial condition, you will be like any zero initial condition you will be provided. Can't we say that it is going to be the solution? Zero initial condition, if we are provided with zero initial condition, so cannot we say that it is a solution? Now you can say that how you are going to define it on 0. So this is a function exponential of minus sum over t over square root t. So you will use the Leibniz rule to make its existence at t equals to 0, isn't it? If you will use Leibniz rule, and using the Leibniz rule you will differentiate it and you will differentiate it, and then you can say that okay, it is existing at t equals to 0, it is defined at t equals to 0. So it is defined at t equals to 0, and every time we have chosen the constant is equals to 0. So under the initial condition with 0 initial condition, this is going to be a solution of the heat equation. Now we are writing it t is greater than 0, because at the first view, if you are going to see it, then you will say that oh, it is not existing at t equals to 0. So we will simply say that okay, just write it for t is greater than 0. Who is gonna use the Leibniz rule? So you will say that for t is greater than 0 and for x is belonging to r, this is a solution of the heat equation ut is equals to uxx. And I said that if suppose this is u1, if u1 comma dot 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 un r n solution of the PDE ut is equals to uxx for x is belonging to Rn. I would not say this uxx, this is Laplacian of u now, because this will be u x1 x1 plus u x2 x2 plus dot 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 plus u xn xn, where x equals to x1 x2 comma dot 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 xn. So in that case this will be u1, u2 can be written as the same as in the same way un can be written, and if you multiply them together, if you club them together, then using this identity, which was the first point I was telling, you are going to multiply this equation. You can say that u x1 x2 comma dot 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 comma xn comma t, or you simply can say ux comma t will be 1 over t to the power n by 2. You will multiply it n times, and exponential of, now since here it was a single x, so it came x. If it has n x, so this is the distance from the origin, so the distance of the origin will be minus modulus of x square over 40. This is going to be the solution of nth order heat equation. This is going to be the solution of nth order heat equation. So what we did, we calculated the solution of the first order heat equation. First order, I am saying that, or you can say that the solution of the heat equation in one dimension. So this is the solution of the heat in n dimension, because it is not possible to calculate the solution of heat in n dimension. You can calculate in two dimension, like ut equals to uxx plus uyy, but as soon as you proceed this, you you increase the dimension, it is going to be very 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 complicated. So making an observation, like the author calculated it for the one dimension, and also some of them calculated it for the second dimension, and then make an observation that the solution is going to be of this form, and then on the basis of that you can say that this is going to be solution of the n dimensional heat equation. And now I am going to write the definition of the fundamental solution of the heat equation. The function phi x1 x2 comma dot 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 xn comma t is equals to 0 when less than or equals to 0 and 1 over 4 pi t n over 2. Why this 4 pi is coming, I will tell you. Minus, we are going to prove why this 4 pi is coming, so just wait and watch. T is greater than 0 is called the fundamental solution of heat equation ut is equals to Laplacian of u. Now our aim is, okay, just tell me one thing. What is the meaning of fundamental solution? Do you understand? If you remember about the fundamental solution, which I was keeping in the term of the Heaviside function, I was not telling that if the Heaviside function was going to be the delta function in that case. So the Heaviside function, like it was coming like some Heaviside function and dx and then integration over the domain omega, it was coming to be unity. Do you remember about the fundamental solution? If you go back in the unit 3, I was saying that the fundamental solution was written in the term of the Heaviside function, so that it was making it 1 in some region and 0 in the another region, is not it? If you remember, then it is fine. If you don't remember, then you need to read your unit 3. So I am gonna prove that adding this 1 over 4 pi is going to make this function from minus infinity to infinity phi dx is equals to 1. So that's why this forms as a fundamental equation. This is also a solution, but for that you are going to get like pi of dx equals to 4 pi to the power minus to the power n by 2. So to make it 1, what we did, we divided it by 4 pi to the power n by 2 and then it becomes 1. So that forms a fundamental solution. And since it is really difficult to prove it in n dimensional, so in one dimension you can say that minus, in n dimensional it will be over Rn phi dx1 dx2 dot 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 dxn. It is going to be like 4 pi to the power n by 2, but in one dimensional it will be phi dx, it is going to be 4 pi root, and that is coming to be 2 square root pi if you don't take it 4 pi here. So that's why what we did, we multiply it by 1 over square root 4 pi, so that this becomes 1 and we call it a fundamental solution. So how it works, let's prove that. Since we are taking the integration with respect to t, so simply we can take 4 pi t to the power n over 2 outside, and it will be integration over Rn e to the power minus modulus of x square over 4t d of x. Now you guys can see that This is the distance from the origin in n dimension. So how we will integrate this integration? Simply assume that z equals to modulus of x over 4t. So dz is going to be not modulus, just x. dz is going to be dx over 40, treating t as a constant, and substitute this one in this equation. So it is going to be 4 pi t to the power n by 2 integration over Rn e to the power minus modulus of z square into dz and multiplied by 4t. So it will be coming like uh, I made a mistake. What mistake I made? When we are going to take z is equals to modulus of x over 40, we cannot take it directly. We have to take the direct sum of these things, because this is the distance. So it will be like z equals to modulus of x under root of x1 square plus x2 square. So under root will be cancelled by this square. So it is going to be make it very difficult. Just do it in one dimension, and then you can see it in n dimension. Suppose in one dimension, in one dimension, modulus will be reduced to just minus x square over 40 dr, and then you can take z equals to minus x square over 2 square root t whole square, 2 square root t whole square. So dz will be, oops, minus x over 2 square root t minus, don't take minus sign, just take this. So dz is gonna be dx over 2 square root of t, and then you can write it like 1 over 4 pi t square root, just integration from minus infinity to infinity e to the power minus, now z equals to x over 2 root 2 t. So it is going to be e to the power minus z square into 2 root t d of x. Now you can see that this 2 will be cancelled out, this 2 and this root t. So it will be simply, I'm writing here, 1 over square root of pi integration minus infinity to plus infinity e to the power, and this is dz minus z square dz. What is the value of this integral? Do anyone know what is the value of this
It's
integral?
it's the
Hmm?
square root of pi over 2. Oh, no,
It is
it's
just because
the
it is
square root
minus
of pi. Yeah, the square root of pi. This square root of pi. Yeah.
yeah, so it is minus infinity to plus infinity. If it was going to be from 0 to infinity, then the pi over 2 will be coming. So this is coming to be 1. It means you can simply see this in n dimension as well, but to proceed it in n dimension, you have to use uh, some theorem from the probability, like some direct sum. So you will consider this g equals to this and modulus of this, and then dz will be coming like, because modulus of x you are considering, so it will be coming like in the direct sum. So that is going to be make it difficult. It I have given it in the notes, you can go over that and it is easy. But in the one dimensional it is very easy to grasp how we are getting this, isn't it? In one dimension it is very easy to see how this is coming to be one, isn't it?
Yeah.
Is it clear how I am getting one in one dimension?
Yes.
Is there any problem? I think that I won't be able to complete the class because I think my voice is not delivering to you. Is it? Is there any problem in my
No.
network?
No.
Oh, then fine.
No.
So
Yeah.
we are getting one. So because of multiplying this constant, we are getting one. So this is working as a fundamental solution of the heat equation, because the integration of this solution over the volume, not over the time, over the volume is giving us one. That's why this is a fundamental solution of the heat equation. Now we are going to see a very beautiful thing. But before that, I would like to ask you, here I am writing another way to solve the heat equation. Would you guys go over this method yourself, or again I should also proceed in this way? What do you want?
Um. This is the heat equation in dimensions.
Sorry.
This is the solution of the heat equation in n dimensions.
That is also the solution of the heat equation in n dimension. Here I am also taking one dimension. You can't see that I am taking x only. Hello.
Hello?
Hello. Yeah, I cannot do anything with my network. Sorry. So this is also in one dimension, but here I am using a different approach to solve the heat equation. So shall I also explain this, or you will read yourself?
You are using as before like a scaling, right?
Sorry.
You are doing like before a scaling.
Yeah, it is little bit different, not exactly same, it is little bit different, but yeah, almost same. So I would ask you to read this. I don't think that I am gonna proceed with the class because really it is difficult for me to hear you. So we tomorrow we can meet over the exam, and I think that the next week I am gonna proceed with the class.
Um, so on Wednesday we're going to take the class, right?
I will write an email about the same, whether I am going to teach you or not on the Wednesday. But tomorrow we have an exam.
Yes. The assignment the assignment 8 will come in the exam.
At the same class time from
The
3 to
topic,
5.
huh?
The topic is Unit 3.
So
Am I audible?
yeah, I can hear you.
Yeah, so the
You
topic
are
is
you
Unit
are
3.
audible.
Yeah, Laplace equation.
But the assignment 8 is heat equation, right? It's of the topics.
Yeah, I'm not going to give it in the class. I'm not going to give it in the exam. The exam will be only based on the Unit 3 heat equation. Sorry, Laplace equation.
Okay, just elliptic
Yeah,
equation.
I will also write an email
Laplace
about the
and
same.
Poisson.
Yeah, Laplace. Is it clear to everyone?
Yeah,
Yeah.
The
Laplace
exam
and Poisson's equation.
is based on Unit 3, that is Laplace
Poisson kernel.
equation. Yes, I put it in the chat, and we are going to meet at 3 p.m. tomorrow. Okay, so see you tomorrow. Bye.
Bye.